Hello everyone, welcome to Code Uplifter. Today in this video we will be understanding about the distributed systems, particularly the distributed database and how the big techies like Google, Amazon and all those companies, how they really handle their data, their lot of data. So how they exactly do their data handling through sharding and replication. Would also understand one of the core concept of sharding called consistent hashing and normal hashing techniques. So let's understand all those things. So just 1 second, let me pull this up. Yeah. So what is distributed database? For example, let's understand you have opened a very big company and you have millions of user or billions of or trillions of user. Now you need to keep their records, user records, and you need to handle all these transactions of this user. Now think of a situation. A trillion of user, each user record is having lot of data within it, and one database, single database, cannot handle storing all those records, because there is a limit to vertical scaling. Either you can scale it up through vertical means or through horizontal means. Now if you scale it up vertically, there is a limit to it, so you can't store beyond a certain limit. So one thing is to handle the scalability, and think that if at all you have stored everything within one database and that database went down, then it is the single point of failure. Okay, now you don't want that, right? So single point of failure we always want to avoid while we design any system right? Now also we want performance. Let's say a single database to handle all these transactions. Now definitely it will not be performant if at all we bring some additional thing, right? So basically these big techies like Google, Facebook and Amazon, they definitely do something to handle all this. Okay, so what do they really do? So they do sharding. So sharding is a method of this to split the data across multiple database. So each database is called shard. Okay. Now each shard contains data. Okay. Think in a very simplistic manner. If I will say, let's say for example, you want to store users. Okay. Now users name can vary from A to Z, and let's say you think that okay, now my user size has really grown up and I need to store users name starting with A to M in shard 1 and N to Z with shard 2. That you can definitely do. That is called sharding. So may term very weak, but the thing is, the core concept is this one. You need to distribute the data between different shards. Now listening this, it sounds simple, but it has its own way of handling all those things. Otherwise there are a lot of complexities within the tech. So we'll try to understand it very briefly. Now if you go to find different types of sharding, one is like range based sharding. Let's say for example with ID 1 to 1000 or 1000 to 2000 in shard 2. So in this way you can distribute. Now there is also one more, hash based sharding. What is hash? For example, your name or your ID is something, a UUID, then you can make a hash of it using any hashing function. Then you can actually make the remainder with the number of shards. Then the remainder that you get, you can find that exactly in which shard your data is going to be stored. So this is called hash based sharding. And otherwise you can, let's say for example, consider let's say US based regions users, you can store it shard 1, Europe based in shard 2. So that is also one way of sharding. But that actually really it can impact the network latencies, because if you, let's say, US based region users are stored in US database, a database which is there in US, then definitely it will reduce the latencies. Okay, now this is all these types of sharding. Now coming to replication. Replication is nothing but actually copying all the data from the master database to slave database. So why this is done? This is done for basic purposes like let's say your master goes down. Now at least the replica should be there to handle all those requests. Now sometimes it is also for some reporting tools. Let's say you want that all the reporting related read operations should go to my slave database, unless unnecessarily I don't want to intervene the master database. So that also you can use replication for that. So there are different types of replication, like master to slave replication. As we all know, master to master replication is also there. For example, you want that, okay, there are two masters and a network request is distributed according to the percentage wise through the Istio, then that also you can do. And P2P replications is also possible. So these are actually different types of replication. Now we will actually deep dive into the techniques of sharding. Okay. Now, why we are actually considering sharding as a very complex phenomenon? I will try to understand here, make you understand. So let's say this is shard 1, this is shard 2, this is shard 3, and shard 4. Okay. Now, for example, your this shard 1 size is also full, shard 2 is also full, shard 3 is full, and shard 4 is all full. I mean, all the shards are full. Now you want that, okay, additional shard to be added here. Okay. Now this is a additional shard you want to be added. So think, okay, how the load balancer decides that in which shard the data is. For example, let's say you want to store a user info. Now that user info, while before it is getting saved to DB, now it is saved according to some hashing logic. Let's say that user's ID comes under hash or comes under this is, let's say, hash 1 or hash 2 or hash 3 or hash 4. Then accordingly it distributes the data. Now when, for example, a user having ID as, let's say, hash key as 2, it will come to this database. Now next time when the user wants to retrieve the data, load balancer should point to second number database. Otherwise, if at a load balancer will forward the request to shard 1, definitely it will not find the user record. It can give errors actually. So similarly, so due to this hashing function, this load balancer has the capability to know that which record is present in which shard. Now when the fourth shard is added, the hashing function has to be changed over here. The load balancer has to change the logic of deciding the hash first of all, so that it can accommodate fourth number hash. Otherwise it will still be sending the fifth number hash. Otherwise it will still be sending the records to only these 4 shards. Now the hashing function needs to change first of all, but think of those data which is already present in all these shards 1, 2, 3, 4. Because the hashing function is changed, now the output of this hashing function will vary. Maybe the data belongs to first shard. Now due to this change of this hashing function, it will give you the data might be present in third database, which is wrong actually. So the problem is that if you add the fifth shard, you need to change this function, hashing function, as well as you need to reshuffle all this data between all the shards, which is a very complex, which is a very expensive operation, and that you never want to do in production systems. You don't want any downtime, and to reshuffle all this data, you want a downtime, right? Now that's a this is actually normal hashing. So if at all any fourth database comes, you need a downtime to reshuffle the data, otherwise this load balancer logic will not work. Now a very well-known concept called consistent hashing comes into picture, whereby all the shards of the database are arranged inside a circle of the hash. Now each key is being distributed to the nearest nearest shard. So for example, a hash value hash key came within this range, then it will be arranged to this shard. Similarly, the keys or the data goes in for redistribution, for the distribution on the shards. Now think that, okay, the fifth shard, let's say a fifth database got added right now. So this is the fifth database. Now you think that whatever the data was earlier going to this shard number, let's say this is shard number 1, has to be redistributed between this is fifth shard and shard number 1, right? Some of the data from here to here will go to this DB, and from here to here it will go to this DB. Now, so think like up to this certain range of data which is already there in this first number DB, it is never going to be migrated. It is not required to be migrated to fifth number shard. But all this data which is already present in this range of data, which is already present in shard 1, needs to be migrated to shard 5. So this only small portion of data, we can say, maybe I can change the color a bit. So you can say the fifth so this thing needs to be migrated to from shard 1 to shard 5. Okay. Now this brings less downtime, and the migration is will be very much efficient as well, and all these shards, fourth, third and the second shard, will not be affected. So only a percentage of users will be affected. So this is the so this brings us very much efficiency in this process. So this is all about hashing, consistent hashing, and all about database distribution. Thank you for watching this video.